Hello programmers! I've got a class pet and my pet class has a private field name and two public functions. One is a constructor. It's not a default constructor because you need to pass in a string, and I've also got a display function. So let's see what happens. In main, I want to create an instance of a pet, and I'm going to pass in the string sunshine, and we're going to try to use that string to set that private field and then just print out constructor for pet. And that part runs okay. When I run it, I see constructor for pet sunshine. But when I try to call the other public function, the display function, then it says the pet is, and I seem to have lost my pet's name. So if we look at the code closely, there's one suspicious line, and that's line 16, where it says name is equal to name. Well, that seems a little fishy. We're not used to doing that kind of thing in computer science. And it turns out that both of the times we're talking about name, it's talking about this variable that's local to this function. It's not talking about the name up here. Well, there's a couple of ways we could fix this. Number one, if we just gave this a different variable name, then it would be able to differentiate. This is what was passed in parentheses, and the name is what we wanted for our private field. So then there's no problem, and we'll be able to run this, and we'll see that the pet's name is Sunshine for both functions. There's another way to solve this. If you really insist on having the same variable name here, then you can use something called the this pointer. Now, I'll show you the syntax first. So with pointers, if you want to actually get to the data that is inside of a structure, you'll dereference the pointer and use the dot operator. And it's the same for structures and classes, whether you're dealing with the field of a structure or the field of a class. So there's this way to deal with the object. And what do I mean by this? Well, I mean whatever object it is that was calling that function display, or in this case, whatever object was calling the function for the constructor. So this is that spot in memory, a pointer to that spot in memory where that pet object, cat, is stored. And there's another way to deal with pointers. Instead of doing it that way, we can use the pointer to a member operation, and then we'll get to that name field, and this will work as well. And I'll just compile and run just to verify that it works. So that was this pointer, and really the main place I see it is when you want to differentiate between a private field that happens to have the same name as a local variable. Then you can use this pointer. All right, another thing that we're going to try with this lecture is a static field. So let's say I want to keep track of the number of pets that have been created using this pet class. Well, we can have a field that is an integer and keeps track of the number of pets that we have. And I'm going to put a new keyword, static, in front of that. And that is going to do something special here. We're going to need to initialize that static variable outside of the definition of the pet class. So I'll say this is part of the pet class. The variable name is num. That matches up there. And then I'm going to give it an initial value of 0. Well, at the very beginning, we haven't created any pets. But after we've created some pets, there will be two ways we can look at the number of pets. One is if we have any object, like this cat variable of type pet, then we can use the dot operator and say, let's look at the number of pets this way. Another way is with static variables, you actually don't need an instance of the class. So we could say the number of pets, and instead of having an object, we could just directly call that, saying I want to talk to the pet class, I want to figure out how many pets they have, and we'll just directly access that static field. So directly accessing a field would only work if you have static here. Let's go ahead and try running this. And right now we only have one instance of pet. That's our cat Sunshine. And so when we run this, we're expecting both of these lines just to print out, oops, actually it prints out the number of pets is 0, because I forgot to actually increment that. I was thinking every time you create a pet, you should increment that by 1. So let's try that again. And then I need to create some more pets other than Sunshine, so that we see that number jump up. And yeah, I see now there is one pet. Well, let's create another pet. let's say that Sunshine needs a friend, and we'll say that friend's name is Fluffy, and we'll have to say that's cat 2. And then Sunshine doesn't really want a dog, but we'll create a dog, Fido, as well. So we have 3 instances of the pet class, 3 objects of type pet. And we run this, and now we see that in both cases, we see that the number of pets is 3, whether we directly just access that or whether we have a variable and say .num. And it doesn't matter which variable I choose here, all 3 of them are looking at that same spot in memory. The static field is just one spot in memory that's shared among all the instances of that class. So static data members are also called class-wide fields or class variables or class fields. So I'll try switching this to dog and running that again, and I'm going to see that whether I'm using the dog, cat, or cat 2, all 3 of those variables are looking at that same spot in memory, and they're going to be able to see that it's set to the number 3.